In this video we are going to first explain the hardware with all the inputs, output, and how to control voltage and current. After that I'm going to start testing this. First I will test the output regulation to see if it can give you any desired voltage that you want at the output. With the input voltage of 30, 24, 15, 12, 9 and 5 volts, we are going to get those standard voltages of 24, 15, 12, 9, 5 and 3.3 volts. Then we will look at the ripple voltage at the output as well. The module has an input voltage of 6 to 40 volts, and the output voltage you can get is 1.2 to 36 volts, and the total current that this can handle is 15 ampere with the current heatsink. And we are going to test it and see how it can handle all this current. Because this device has constant current, it means that if you set the current, let's say for 5 ampere, by rotating this when the load is connected, when the load current reaches the limit setting, for example of 5 ampere that you set, it reduces the output voltage. Here is this module now. Here is the module. We have an input on this left side. If you see the switch in here, so we have a on and off switch that turn this off. There is a power LED here, and then we have these two terminals. The negative is there, the positive here. Phillips screwdriver. It seems they're not that high quality, but one point it has been soldered on this side. And these are the output terminals that you will connect your wires under these screws and then tighten it. And we have two potentiometer here. The first one is here labeled as CV, constant voltage. So with this one you regulate the output voltage. And the second one is CC. This is constant current. And with this one you can set your current limit. There is no meter for that, so you have to experiment and connect a load and then measure the current and then turn this and to see. And then the two regulators, there is one regulator on this side with a heatsink, and then the other one is connected on this side. And the main chip that is doing the regulation is at the bottom with all these components. So when you're using this, make sure that you have enough protection at the bottom, otherwise anything will touch and one of these components, resistor, capacitor, or maybe even the chip will pop out. So it needs protection. But the heatsink have been connected using these two screws here. So this seems to be very solid. This winding is also